Okay, pause and copy. So let's move on to R3, talking about lines again to begin with. So I'm going to draw this a bit differently in R3. I'm not putting my axes. On paper with a pencil, it's just generally not worth your time to be drawing a set of axes and trying to make it super accurate. So we'll do a non-literal drawing. We have the origin here. And then we have a vector v and a vector u oriented at the origin. And in purpley pink here we have a line L. Now in English we say that this is the line that goes through u. Okay, so it goes through this point here and is parallel to this vector v. Okay, so these should be a parallel thing happening here. So I hope you agree there is only one line. So it's the line that goes through u and is parallel to v. And we can write that as we did before. You know, x is u plus some multiple of v. Okay, for planes, a different scenario. Let's try to draw this a little bit trickier. So again, so totally separate. You're imagining a totally separate set of axes here. I'm not going to draw them. Really. So let's put our origin down here. Sure, and I'll try to draw a plane. So what is a plane? A plane is so imagine in 3 dimensions, you have a piece of paper that is flat and extends to infinity in all directions. So imagine if the top of your table extended in all directions to it forever. So it's a flat surface in R3. Okay, so I'll try to draw such a thing. We can't draw the whole thing, of course, but what I usually do is draw I guess you'd say a parallelogram here, or try to make it a parallelogram. So you imagine I'm giving just part of this sheet of paper, but you imagine this is infinite in all directions. And then let's say that we have a vector that is on the plane. So it doesn't matter, we'll take a point here on the plane. Doesn't matter which one I take, and I'll extend the vector there. Oops, I missed it, but you get the idea. Call that u. And then we will take 2 vectors that are parallel to the plane. So I just automatically said 2 vectors. With a line, we had just 1 vector that was parallel to the line. The sheet of paper, the plane, is now a 2-dimensional object, so it's not unreasonable to expect 2 vectors parallel to the plane to be what's required here. So I hope you'll agree. So here's one. Let's say that's v. And I'll draw one parallel to this edge. You don't really have to do this, but kind of makes it look a bit nicer if you... Why not? I'll call this one w. Okay, where to put my face? Okay, so u, we say, is on the plane, and v and w are parallel. So let's give our plane a name. Go capital P for plane. And in English we say P is equal to the plane. That goes through U. And is parallel to the vectors V and W. And we can do something similar to what we did down here. We can say P is given by the equation X is equal to U plus, we'll start with what we had down here, TV. And then we need one more term to form our plane. I'm going to use S as my letter. So that is an S right there, not a 5, an S. Okay, there you have it. That's how we think of planes in our 3 here. One more thing to help you visualize, if this isn't quite helping. You can move this V up here. So let's say I did that. Like that. And then you can take this W and move it. You move it like this. Doesn't really matter too much. That's about that long. That's about, oh, why not? Now you see. So what I've done is I've just taken W, shifted over like this. I could shift it like this, doesn't matter, but I wanted to have it all contained in what I've drawn here. V moved up here. And the thing I want to talk about is this triangle here. Okay, so this side length is the shifted V. This side length is the shifted W. And this side length is just connect the dots. So I sometimes think of this plane P as being the plane that contains this triangle. And it's the plane. So hopefully you can convince yourself that there is only one such plane containing that triangle, and that is what we're talking about here.